Hi everyone. In the last video we learned that why there is a need for indexes. But in this video we'll be seeing the different types of indexes like B plus tree, geospatial index and inverted index. So let's get started. So let's start with the B plus tree first. So over here we have a table with two columns, ID and name, and there are so many users in that table. Okay. So let's say you try to execute this query. So by default, the database will perform a full table scan. That is, you'd have to go through each and every row in order to find a user whose name is equals to Bob. All right. So in order to optimize this, you create an index on this name column. All right. So we'll be creating a B plus tree like this. So you just have to run this command and one B plus tree would be created for you. So the B plus tree would look something like this, wherein you would be having a root node and there would be many intermediate nodes. And finally, you would be having this leaf nodes. And in each node, we would be having multiple keys. Okay, so key is nothing but this names, because we have created the index on the name column. So all these values are nothing but keys. All right. So they are used for routing purpose. So let's try to understand how we route the specific request. So this was the query, right? We were trying to search Bob. So let's see how do we route the Bob. So first of all, we compared Bob with this Frank. If Bob is less than Frank lexicographically, then we would go on the left side. If it is greater than equals to Frank, then we would go on the right side. All right. So here Bob is less than Frank. So we'll go over here. Then again, we'll compare Bob with Bob. So is Bob less than Bob? No. Is Bob greater than equals to Bob? Yes. So we have to go on the right side. Then over here also we have to compare first. So is Bob less than Charlie? Yes, it is less than Charlie. So because of the comparison, we got to know that we have to select this pointer. Okay. So once we select this pointer, we reach the leaf node. All right. So all these nodes are the leaf node. So in the leaf node, you just have to find Bob. And once you find Bob, you can just make use of this pointer to get the page where the entire record for that Bob is present. Okay. So by the way, all these nodes which you are able to see over here are nothing but pages. And we have already discussed what is pages in the last video. So all these nodes are pages, and these pages will only contain keys, Bob, Charlie, Carl, etc. But the actual raw data will be present in a page which is being pointed by the key present in the leaf node. All right. So this is how the entire searching works in the B plus tree, and it is more efficient because here you are not performing a full table scan. Instead, you are just going through few number of pages. So here we went through this page, this page, this page, and finally the page where your row was present, right? So that's why it's very efficient. And secondly, you can also perform range-based queries, because all the leaf nodes which you are able to see over here are connected bidirectionally, right? So if there is a query like return me all the users whose name is greater than equals to Bob and less than equals to Jack, right? So in that case, you would first get the Bob and then you'd start traveling on the right side like this. Okay. So by this, we got to know that B plus T can be used for retrieving a specific value or specific row more efficiently, and it is also efficient in range-based queries as well. So now let's see what is geospatial indexes. So assume that you are trying to find a restaurant within 2.5 kilometers range, right? So the first thing that comes into your mind would be just go through each and every restaurant and try to find the distance between you and that restaurant, and just filter out all the restaurants which has a distance less than equals to 2.5 kilometers, right? So this is the brute force approach, but obviously it would be very time consuming, right? So how can we improve that? Can we use B plus T? No, we cannot use B plus T, because Because in B plus tree, we would have keys which are sorted, right? In the leaf node, all the keys are sorted from left to right. But here we cannot sort this, right? Because here we have two dimension data, latitude and longitude. We cannot sort both of them, isn't it? So how can we optimize this thing? So in order to optimize this thing, the smart move would be to convert this latitude and longitude into one dimension data. Once we do that, we can directly use B plus tree, isn't it? So in order to convert latitude and longitude into one dimension data, we use something called as geohashing. Okay, so let's try to understand how this algorithm works. So first of all, we take the entire world map and try to divide that into 4 parts: 0, 1, 2 and 3. Then again we take one of the part and try to again divide that into 4 parts: 2, 0, 2, 1, 2, 2, 2, 3, and we keep on repeating that. Okay, we repeat that until we get a very accurate position, right? So over here 1 represents entire Asia, whereas over here 1, 2, 3 represents India. So if I keep on breaking this block, I will even get my exact position where I am currently recording this video, isn't it? So this is how the geohashing works. It converts latitude and longitude into something called as geohash, like this number. And by the way, in reality, you would be having a hexadecimal numbers. Like it would also have some characters as well instead of pure numbers. All right. So now if I ask you to find all the restaurants which are present in India, for that what you need to do is you just have to go through each and every restaurant and just check whether that restaurant has this prefix 1, 2, 3. So over here restaurant 1 and restaurant 2 has the prefix 1, 2, 3. It means that they are present in India. Okay. And one more thing, we are currently going through each and every restaurant, right? But we can improve this by using B plus tree or B tree. Why? Because here we have one single column. This is one dimension data, isn't it? So if I try to execute this query before indexing this column, this geohash column, then we have to perform a full table scan. But if I index this column, then we do not have to perform full table scan. Instead, it would be very efficient. Okay. Now, one more question is, what if I want to find all the restaurant within a certain vicinity, like 2.5 kilometers? Then for that, you need to know your current position, right? You would then convert your current latitude and longitude into a geohash value like this. Okay. Then what would you do is you take some prefix. For example, let's say I want to match 5 characters. So I'll take this 5 characters and check which all restaurant has the same first 5 characters. So for example, restaurant 2 has the same first 5 characters, right? It means that restaurant 2 is closest to me. Okay. So basically, if you try to take a prefix which has more number of characters, then it would give you more accurate answer. Okay. And if you try to take a prefix which has less number of characters, for example, let's say I take only first 3 characters, 1, 2, 3, then it would give me all the restaurants which are present in entire India, which obviously I don't want. I just want a restaurant within 2.5 kilometers range, right? So in that case, I have to take more than 3 characters, probably 5 or 6 characters, right? So this is how geospatial indexes work. Now let's see what is this inverted index. So assume that we have the data of all the restaurants present in India. So these are the names of the restaurant and this is the description of that particular restaurant. All right. And now let's say I want to search all the restaurants which has pav in it. Okay. This is the pav, right? So I just want to search all the restaurants which has this pav in the description. So for that, I would be writing this query like select all the columns from restaurants where description like percentage sign, pav percentage sign, right? So this query will return me row number 1 and row number 2 because these 2 rows has this word called pav. But the problem over here is we have to perform a full table scan. That is, we need to go through each and every rows present in this restaurant's table. So in reality, this table would be very huge, right? It would be having millions of rows. plus the description would not be so short. Instead it would be having multiple paragraphs, isn't it? So that's why this query will not be efficient. So how can we make this efficient? So in order to make this query efficient, or in other words, in order to make this full text search, okay, this full text search efficient, we use something called as inverted index, wherein we create a table of two columns, wherein the first column is storing all the tokens. So over here, all these words are basically tokens, okay, like pav, pizza, pasta, butter, etc. They are the tokens. And the second column is the posting list, which represents the list of IDs where this word is present. Okay, so for example, this pav is present in row number 1 and 2, right? So here we have 1 and 2. Butter is present in row number 2. So over here we just have row number 2. Okay, so this is how the queries like this will be optimized. If someone tells you that, hey, give me all the restaurants where we have this pav in the description, then you can directly go over here and get all the rows, isn't it? It's very easy, right? So if you have a requirement where you need to do a full text search on a specific let's say column, then you can definitely use this inverted index. All right, so with this we have understood all the indexes like B+tree, geospatial index, inverted index, and we also saw when to use what. So if you want to do a full text search, you need to use inverted index. If you are dealing with some location based queries, then you need to use geospatial index. And if you want to optimize your search on a 1D column, then you can use B+tree. Further, you can also use B+tree for range based queries as well. All right. So if you like this video, then please hit the like button so that this video can reach to more and more people. Thanks for watching.